Welcome to the session here. This is the last session before our keynote tonight, so we appreciate a lot that you're going to attend this session. My name is Stefan Schneider. I work for Amazon Web Services. This is Peter Schienagel. He works for SUSE. We jointly developed the SUSE HAE extension solution for AWS, which is a public cloud solution. And this solution is very helpful to us since we have 1 terabyte and 2 terabyte instances, which we operate with our SAP HANA. And SUSE is actually our one and only certified operating system on it, since these customers typically are production customers with a high demand for reliability. And SUSE HAE helps us to provide the quality of service we need for our customers. And this is what we want to demonstrate in today's presentation. And we are going to have a kind of 45 minutes slide deck. And then we're going to have a 15 minutes video where I'm going to show you on how you fail something over and how you then reconstruct everything in order to come back with your environment. SUSE is pretty much a founding member of the SAP Linux Lab. They have been working with SAP early on making SAP available on Linux. So SUSE has been leading there, and they never gave up their head start. They're basically as I said, our one and only certified operating system for the X1, our high-end instance types. AWS is working for more than 6 years with our SAP. We have pretty much most NetWeaver and HANA products certified for production usage. And we have a fairly complete offering. And now for a kind of a year since /12 SP1, we have production support for the SUSE HAE extensions. And we have the first customers who install these technologies. And this presentation here is about giving you an idea on what the /4sub HAE extensions are. And I'm going to hand it over to Peter, who is going to give you an overview on how this product is going to work in general.
Yeah, thanks, Stefan. So we will look a little bit what we do with SUSE Linux Enterprise Server in general. And the base of all is really the SUSE Linux Enterprise Server for SAP applications. So it's a bundled solution of our offerings, what we dedicated to SAP customers to make the life or the of SAP customers more easy. So that's where we have started with the SUSE Linux Enterprise Server. And over the time, customers approached us, could I make my SAP system higher available because that's an important system? And so we said, yes, we have a solution for that, our HA extension. And as we built this bundle product a few years ago, then we decided, let's bundle in the HA extension. So we have 2 SUSE products in one offering. The other things we built in are some technical things, but also some support things from the technical scenarios. For example, the page cache management and the installation wizard, or later on the extended service pack support. The page cache management helps with how Linux, the Linux kernel deals with memory. So Linux uses all available memory, free memory for file system caching. And if there's a lot I/O, it will page out the application in favor to have more file system cache. In Unix system, you can control that. In Linux, not. So we did here 2 kernel tunables where you can influence this. And the idea behind that is that the application is more important than the file system caching. So your application is still in memory and performs the same even if there's more file I/O going on, and will be not paged out in favor of file system caching. The installation wizard, on the other hand, should help non-trained administrators to easy install Linux and SAP in one go. So for example, a Linux administrator can install the SAP things, or a SAP administrator can easily install a Linux. Yeah? So this helps here quite a lot. And we try to extend this over and over in the actual version of 12 SP2. For example, you can also install a complete HA stack with that. Other things, as I said, is support. So as SAP systems are mostly business critical systems, we have a 24/7 priority support. And the nice thing is we do this together with SAP. And the idea behind that is one face to the customer. So if you have a problem with your SAP system, call SAP. And if it maybe it's a SUSE issue, then the SAP people will hand over this to a SUSE supporter, which is directly sitting in the SAP ticket system. So you don't need to open a second ticket. So it's still handled through the SAP ticket system. And the extended service pack support. I guess you're aware with that if we bring out a new service pack, we have a grace period of 6 months until you should be on the next service pack. 6 months are for SAP customers quite short because in 6 months you don't get a maintenance window. So we said, how can we help here? And we added here 1 year of additional period. So you have 18 months time to do that. And in the meantime, it's also possible to extend this more because the long-term service pack support is available on a per server basis. But this additional 1 year is built in the product. The additional things you need to buy. So this helps also in the SAP environment. And this is the general idea of the product to help here the SAP customers running their systems. Other things we have in /12, because the main theme of /12 is minimize downtime. So this is a feature we also have for sure in SUSE Linux Enterprise Server for SAP applications. You can do a full system rollback with help of ButterFS, Snapper, and all these things around. So this also helps in the SAP area. Yeah, coming to that a little bit more to SAP HANA. So it's all about business continuity, and you can do with SAP HANA different scenarios. One thing is SAP HANA has built in some HA features, and for example, a host auto failover. You can have a standby HANA, which kicks in if the HANA fails. But for that, you need SAP software and something from the hardware vendor because you need a second machine. And you need to have a shared storage for that. So you need also take care of that the hardware vendor provides some mechanisms to do that. On the other hand, if you have two more data centers which are from a distance wider away, so you can do also storage replication, and therefore you need also a solution from the hardware vendor because they do storage replication. But SAP has also added the so-called system replication. So that's built in the SAP HANA database itself. So you don't need additional things from a hardware vendor. You rely on SAP here. The drawback on this HANA system replication, this takeover is a manual process where you the administrator needs to know the commands, needs to be there right in time. Think about if it's night at 3, it maybe takes a while until an administrator is available. So it could hit your service level agreements. As we have seen before in the SUSE Linux Enterprise Server for SAP applications, we have the HA extensions there. And with the help of the HA extension, we can automate this manual takeover. So this helps here to have better service level agreements. Having a look a little bit more in details how this is working. So as I said, the SAP database replicates the data to the other node. And as SAP HANA is an in-memory database, it does a synchronous replication to the other side. So you have on both nodes the data, and this is something like a hot standby. Yeah? So all data is there, are in sync. So the failover to the other node is quite fast because all data is there. But this system replication takes only care about the database. So your clients need to connect somewhere, and therefore you have normally an IP address. But if the failover to the other machine, there's no IP address because normally the clients connect here. You can reconfigure your clients, and if we have a lot of them, that would be a lot of work. Or let our automation, the HA extension, use that. We can move a virtual IP address to the other node transparently to the clients. So this we also automate more than the HANA system replication. And on the other side, then we also take care if the communication if the communication between the two nodes will fail. So then you have two nodes which think about they are alone and will become master, and this normally will hurt your data. And for this, we also take care of the fencing. So that means we make sure that only one node survives, and so your data is better protected or protected at all. So this is what we additional do. And as we looked at the solution in the Amazon space, we need to do some special things at Amazon, and Stefan could explain this. The first step is you need to prepare the environment because we don't have hardware. We are in the infrastructure, and need to do a little bit more.
If you run your computers in AWS in the cloud, it's pretty much like a normal data center, except that AWS is controlling the network strictly, and AWS is controlling the lifetime of your instances strictly. If it comes to the network, you're going to take the IP address which is getting assigned to you by AWS. Don't try to broadcast something. Don't try to host another IP address. It's not going to work. You're technically sitting in a single confinement. And this is the reason why the SUSE cluster has to ask AWS to change IP addresses, and the SUSE cluster has to ask the AWS infrastructure to stop or start instances. And since stopping and starting instances is something fairly severe, we have to make sure that these cluster instances are privileged to do this, because you don't want to make sure that they don't shoot around and shoot any other instances in your environment. And this is why you have to this is why you better read this SAP note and take some precautions with IAM profiles, access rights, and abilities when you set up your instances. And you really want to read it before you read the SUSE setup guide, and you really want to read it before you create your instances. If you just install your HANA and then try to add things after on, then you figure out it's too late for a number of things which are important to do these magic tricks which we have to do for the SUSE HAE extensions.
Yeah, and this is really needed because we, as from the cluster side, we can't control the infrastructure. We need to talk to the infrastructure doing things for us. So, but after that, it's quite straightforward. Install your SAP HANA like it's documented by SAP. Configure the SAP HANA system replication like it's documented by SAP. So then you can play around with that. And then add the SUSE cluster packages, initialize them, and then you still need to tell the cluster the rules, how he should react. And also for that, we have a small wizard which creates these rules for you. And it's really a very simple step, 4 steps. And the only thing what you need to enter is the SAP system ID, the SAP instance, and the virtual IP address. So the only 3 parameters, and then the wizard generates the rules for the cluster and push it to the cluster. It's all delivered in the SUSE Linux Enterprise for SAP. It's not in the HA extension because it's dedicated to HANA and SAP. The resource agents, the wizard, and also a guide how to set this up. As I explained, there's one scenario to have a hot standby, but SAP HANA has much more modes how you can run such a system replication. This one is in a more mathematical approach here to express that. And this is the first scenario. You have an active in-memory replication to the other node. The benefit is it's really fast, therefore we name this performance optimized. The drawback is you cannot use your second node for anything else. HANA nodes are big nodes, expensive nodes. Also in the cloud, you need big machines. And therefore, this is the scenario we do here. Benefit is takeover speed. Drawback is you need a second machine, which is doing nothing as waiting for a fail of the first machine. As I said, HANA could do more. Another idea is here, do on the second node something else, but then we need to free the memory. So HANA could do that. There's a mode which the HANA database writes the data to the disk. So we have the memory free for maybe a second HANA, which is your QA system. So we can do something with the second node. The drawback of this solution is that the takeover speed is quite slow. Because in a takeover case, we need first shut down the running instance here and then do a cold start of the primary system. And if you have big SAP HANA database with a few terabytes, a cold start could take hours, depending on the size and the I/O from disk to memory. These are the basic, 2 basic scenarios. All other modes from HANA could be in the background are these 2 modes, performance optimized or cost optimized. SAP also could do some logical databases in a HANA database, multi-tenants. For us, for the system replication, it's transparent because the system replication always replicates the complete instance and not the logical databases. So it comes back to performance optimized or cost optimized, so no change from our side. Other scenario is a more DR scenario. So you have your synchronous replication from A to B, and then you have from B to C an asynchronous replication where the distance could be much, much longer. And for us, from the view of the cluster, we don't care about node C because that's not reachable from the cluster. That's maybe too far away with different distances, with different latencies. And we don't be sure because it's an asynchronous replication if the data is really synced and when it's synced, because we don't have control of that. So we are back to a node A to B synchronous replication, and that's performance optimized or cost optimized. So we're back to the same scenarios. Yeah.
So it can be also a cost optimized scenario. So it doesn't have to be
right. Yeah, could also be cost optimized. Yeah. Yeah. So the quick recap: what the HANA system replication could help for. It reduces really the complexity. The wizard does an easy install. It reduces the risk because we also check the consistency of the database. If we are allowed to do a failover, because the databases needs to be in sync. If it's not in sync, we will not fail over and destroy data. So we all take care of these, and this increases the complete reliability of the solution. In the Amazon cloud, it looks a little bit different, as we've heard. So we have some special circumstances because we need to talk to the infrastructure and not to the hardware. And this is what Stefan will show you.
Okay, thank you. Take care that you're not going to step on my tail here. So, this is now my section. Whoops, this was my watch. Just now to make sure that we complete in time. If you have your installation at AWS, you typically pick a region. A region is US West Coast, East Coast, Ireland, Frankfurt. And a region consists of multiple availability zones. Availability zones are basically data centers which are 10 to 50 kilometers apart. And they are supposed to be fairly independent of each other. What we are going to do in our demo is we're going to run two HANA systems. This one is going to replicating to the other one. And I'm going to show you on how SUSE HAE is going to protect things. Don't worry, this slide is going to come up again. We have some additional filler slides here for cases where we don't show the live demo. SUSE customers typically distinguish in between high available solutions and disaster recovery solutions. Typical customer on-premise tend to have their own data center. They tend to have problems in getting into another data center or remote one. Therefore, they have their servers in the same data center, and they do the switch over inside the same data center. If it comes to AWS, we basically always have multiple data centers in a region, and it's not going to make a difference if it comes to your costs, whether you operate both instances in the same data center or whether you operate them in two distinct data centers, because the bandwidth in between the data centers, the availability zones, is still good enough. And therefore, we basically recommend just go for the disaster recovery option, install your things in multiple availability zones, have your two HANA systems 10 to 50 kilometers apart. This is going to harden you against individual disasters. It'll harden you at least against the nuclear strike, well, against a tactical nuclear strike. And therefore, our recommendation is simply use the availability zones, which we give anyhow to you, and keep your things some 10 to 50 kilometers apart from you. And this is something you can do in all of our 13 or 14 data centers worldwide. We apply to the same strict rules there. Our technology is going to work pretty much everywhere. Another thing which is a kind of special with AWS, as I already told you, we manage the infrastructure. We take care that accounts don't influence other accounts. We take as well care that every instance is getting its own bandwidth. And therefore, we have some more or less strict, and therefore we have some more or less strict rules. One is security. We're shielding every instance with its own firewall. We take care that no traffic is going to happen outside of the IP address the instance is supposed to do. And therefore, these SUSE systems need some special privileges, because these two SUSE cluster nodes want to do nasty things. They want to shut down other nodes. We have to add special policies to make sure that these two nodes are only allowed to shoot themselves, but not any other third or fourth system. And therefore, we have a fairly elaborate security environment where you have to grant these rights to the instances, and you have to grant these rights at creation time of the instances to them in order to make sure that they can do their games in shooting each other only to itself. Another aspect is, and I'm going to show it to you, we are auditing our entire environment. You can flip a number of switches. We have a technology called CloudTrail, where we document severe changes to the total configuration. And if a cluster is going to fence each other, we are going to create CloudTrail entries where you can see who shut down the instance and when it got shut down. And this is extremely helpful to figure out what happened. And we use this as well for messaging, because we can trigger short messages or emails or other functions if these kind of events happen. So if a node in a SUSE cluster is going down, and you have CloudTrail enabled, you'll get a log on why and how this node got down. And I'm going to show this in my upcoming demonstration. In my demonstration, I'm going to put my 2 nodes under control of SUSE cluster. And the SUSE cluster is going to monitor the HANA system replication and a service IP address, which is being used for communication. I'm going to explain this again in my demonstration. This is another example when the pacemaker is deciding to shut down systems. It's going to submit a call to the EC2 infrastructure, and then AWS is shutting down one node or the other node. Or if the cluster decides that a virtual IP address needs to be swung over to another node, then it's submitting an API call to our infrastructure management, and AWS is going to switch the routing of this IP address. And this is why we need 2 special agents, and these agents are available for production use since /12 SP1. We have quite a number of customers who use this technology. And besides these 2 AWS-specific agents, you can do whatever you want to do with your SUSE cluster. All the other technologies are completely transparent to be used. This is the Stoneth fencing. If one of the nodes gets a feeling that he can't reach anymore the other node, then it's going to ask our AWS to shut down a given node. And you're going to see on how this is going to happen. This is another slide describing the Stoneth stuff. Even if these 2 nodes can't talk anymore to each other, they're able to communicate through the AWS infrastructure network. And this node here is able to ask EC2 to shut off our node 2. This is the fencing agent. This slide is from Marcus, who's unfortunately sick today. He has been describing on what to do. We have commands like EC2 stop instance, which allows you to programmatically shut down instances and put them to rest. We are tagging as well the EC2 instances in the AWS infrastructure to allow the cluster to identify members of the cluster. We use a thing called floating IP address, or in AWS terms, this is an overlay IP address. And with this overlay IP address, AWS is able to route traffic to one node or the other node. And we were able to do this across availability zones. So AWS is basically warranting that even if an entire AZ is going down because something happened there, maybe someone has been digging a trench 20 meters deep around one of the AZs, that this is going to happen. And what the SUSE cluster is doing, it's updating routing tables in AWS to make sure that the traffic is flowing to the remaining surviving node. This thing is here explaining it in more detail. The cluster is asking AWS to migrate such a floating IP address from one node to the other one, and this is happening by updating the routing table in your virtual private cloud. And then all the traffic goes immediately to the other node, and this is something which is extremely fast. It happens at a sub-second level because it's just an entry in a routing table. It's important to read this note here first. In order to do these fairly extreme stunts, you're going to need special rights and privileges. And these privileges have been assigned to these nodes here. If you give these rights to any instance, you are very likely to ruin your entire network. So the SUSE cluster nodes really need to be privileged to execute these things in a safe way without creating harm to third parties. Okay, so let's check the time. We are pretty much in time. I'm going to need 15 minutes to run you through my demonstration. And I'm going to do this. And I'm not going to do a live presentation. I recorded such a failover scenario home. The point is, I didn't know whether I have a good internet access here. The commands I have to enter are difficult, and I want to give you a good experience. And last but not least, there are some sequences which take longer of time, and I simply cut it out of the video. So we're going to have a node called SUSE Node 51. This is our HANA node. It's running our SAP's HANA. It's using 6-7 disks, which we attach by software to it. And this is where an application server from SAP is pointing to. And it's not talking to it directly. It's talking to it through a service IP address. And this service IP address is a kind of pointing to this leading node initially. So if you want to use this solution, make sure that you use this service IP address, which is going to be switched forward and backward by the SUSE HAE cluster. This HANA node here is replicating its state to another node. This SUSE 51 is running in availability zone A, some 10 to 50 kilometers apart. We have another availability zone in a different subnet, and there we run this secondary node. And this secondary node is getting all changes from the primary node, and the SUSE HA cluster is taking care that these two guys are healthy, and it's monitoring the system replication as well the monitoring of the service IP address. The blue screen here is the one from the application server. I'm doing initially a check whether I can reach my leading node directly with a ping. Then I'm checking whether I can reach SUSE node 52 directly, and then I'm checking as well with a last ping whether I can reach my service IP address with a ping. So I can see all systems. It's important that the application server is using SUSE Service 5 to reach the HANA system. The terminal with the white screen is my leading HANA node. This is SUSE node 51. I'm typing CRM status. This is the command line to show me what the cluster is doing. You can see a happy cluster. It's running a standard agent, which is started on the node. It's running an agent, which is monitoring our floating IP address. And it's currently registered node 51. It thinks that our current node is the master, and the secondary node is node 52. So this is one happy family. And the cluster is up and running. Everything is fine. I'm now going to become the SAP admin. I'm going to check with HTTP info whether my HANA database is up. You can see here these are the processes you need to run the database. So at least the processes are up and they're doing their job. Then I'm using this command here, https util as our state, to check whether my primary node is replicating to the secondary node. And you can see here that my node is a primary node. The node is online. Its ID is site1. Its name is WDF. And it's actually the leading node. And it's replicating to SUSE node 52. My third terminal here with the yellow background is my secondary node in the other AZ. I do the same. We should do the same stuff. CRM status is going to show me exactly the same because both systems are communicating the state with each other. And they both agree that SUSE node 51 is the leading node. I'm going to type HTTP info. My secondary HANA system is basically an identical installation. It's running as well. It has all the processes up here. And then I'm going to check on whether this is a leading node or a trailing node with https util minus sr state. And here we are going to see a difference. Here we are going to see that this is a mode in syncing mode. Its ID is 2. He thinks its name is road. And the primary node is node number 1. So this was just the status check in order to check whether everything up and running. I used HANA Studio as a client on my application server. And this is basically an admin view where I can see that, for example, SUSE node 51 is replicating its data to SUSE node 52. And this is a happy system, except for one warning, I didn't pull a backup. But backups are important for production customers. This is yet another view. This is the AWS console. You can see we have the two instances here. Both are running, and everything looks fine from the AWS point of view. You can see the IP addresses here. So this is pretty much what I described here. I've been showing you the state in the three systems. And now we are going to do the nasty stuff. Now we are going to bring down this server, and then we're going to see what is going to happen. And we are going to bring down the server by shutting down its network interface. Our Amazon instances are typically connected by one network connection only. And I'm now here on SUSE node 51. I'm super user. I'm typing ifconfig eth0. eth0 is hosting my IP address, which is being used for pretty much all traffic, and it's being used as well by the cluster to coordinate traffic. And what I'm now going to do, don't do this in AWS and don't do this at home. I'm going to shut down this command here. This instance will be a happy instance, but it won't be able to talk to anyone more. It's in single confinement. So I now went over to my node 52. Let me step back a bit. And I now went over to my surviving node, whereas my node 51 is nosediving. And I typed in CRM status. And this thing shows you that node 51 is in an unclean status. It depends on how you configure your probes, on how quickly you find out on what's going to happen. And the SUSE cluster is going to take action now any second. While I'm leaning back and I'm being curious, I'm checking my AWS console. And here I can already see someone is stopping my node 51. So the cluster already took action. It's shutting down my node 51, and node 52 is still running. This has been the guy who has been shutting down his buddy. Now let's see what's going to happen from a point of view from the application. I'm clicking here on my stuff. Some things have been cached, and it got stuck. So a moment later, I'm back on my surviving node, CRM status. And here you can see now it switched the IP address to SUSE node 52. So the service can move ahead. It changed the synchronization status. It made node 52 the master. And business basically can move on. A user who is using the database is going to figure out that some things are wrong. I'm punching a bit around. The HANA Studio is going to reconnect. I'm going to remove this error message here. And after it's reconnected, it tells me that the same database server is now being hosted on, that the same database server is now getting hosted on, SUSE node 52. Just a second, this was a bit too fast. Here I'm trying to force a database reconnect by clicking around. I'm removing the message. So here you can see in the system status, it's now showing me the processes on SUSE node 52. It's now doing its job against 52. By this point of time, normal business is moving ahead. Assume that such an error would have happened at 2 a.m. in the morning. The users would have had a minute or maybe two where the service wouldn't have been there. After a minute or two, the service is back there. The admin is hopefully in bed. And normal business operation is moving on. This is the real value of the SUSE cluster. Even when you don't have someone who's monitoring things, then it's switching over things, and the business is moving on using the secondary node, which now became the primary node. What happened in the background is it changed the IP address. It made the other node being the leading node. And for the business users, the emergency is now being solved. And if you go to the AWS console, you see my node 51 is stopped. My node 52 is operational. And this is now CloudTrail. And CloudTrail is our auditing component. It needs to be explicitly enabled. It's going to cost you some pennies a day. And here you can see that this entry here basically stated I logged myself in at 10:15 this day. And then I started the recording of my session. And here you can see that at September 16th at 10:20, this user, and this is an instance ID, initiated a stop instance command. And it actually, this guy here, this is node 52, actually issued a command to stop an instance, and it stopped this instance here. And this is getting documented. This is audible. And AWS has technologies like SNS, which allows you to pipe this information into a topic. and you can send a short message to someone, you can send an email to someone, you can trigger a Lambda function, which is gonna do something special. And at this point of time, if your admin did decide to do this, he would get a short message and then he would get woken up. So this is a nice benefit which you get on AWS because we have the entire monitoring and auditing infrastructure to do these kind of things. Yep. So now fast forward, now it's 9 a.m. The admin didn't get his short message. The admin is coming back to work. He is seeing node 2 as being stopped. Something went wrong with our primary node. We have no idea whether the motherboard was breaking, whether the motherboard had an ECC error. We don't know whether SUSE maybe had a problem, maybe file system ran full, or whether SAP HANA had a problem. And for this reason, we configured the system, and this is what we recommend to customers, to let the system down, because it'll take in further inspection before you take this node back in service. The current problem is we have basically an engine running on 2 cylinders. We lost 1 cylinder. We lost our capability to survive yet another disaster. And in the remaining demonstration, I'm going to show you on how you reintegrate the cluster node which we lost. And depending on what your production system is doing, you want to do a careful inspection of your failed node. You really want to check out on why it failed. And only after you're sure that you remove the cause of the failure, you will want to bring this node back in service because you want to have a high available solution again. So I checked my stuff. So the first thing I do, I restart my instance. If it failed because my motherboard burned out, AWS is going to give me automatically a new motherboard. I'm going to reattach my disks. The system is booting. And after a minute or two, the system is up there and running. This is going to take, as I said, a minute or two. And then the next step is I'll have to log into my system because currently the HANA replication has stopped. HANA isn't running. Cluster is actually not running as well, and I have to reconstruct my high available configuration in order to be able to swing back if the next disaster is potentially going to happen. So here I probably needed a bit too much time. Let me forward it a bit. So what I'm doing here, I'm logging in through SSH to my SUSE Node 51. I become super user. I check my cluster status. There is none because the cluster software isn't running. The next thing I'm going to do is I'll become SAP admin. And I'm going to check the status of my HANA system. I type HANA info, and you see nothing but an admin process is up and running. So what I'm now going to do is, if I would start it now, this thing would think it's a leading node as well. At first, I have to teach my HANA instance with this command here that it's supposed to be a trailing node and that it's supposed to receive information from node 52 to sync as well. I'm changing its role from being a leading node into a trailing node. This is just a configuration and change. This is just a change in configuration. This command happens fairly fast, and then I'm going to start up my HANA, and I'm sure that it's going to start resyncing everything it had. This is going to take a moment. It can take up to an hour. It can take up 1.5 hours, depending on the size of your system. I'm shortcutting it, and after a while, this system comes up. This is SAP technology. This is nothing which we have under control. After the system is up, you see here the typical scenario. All processes are running. And if I check my synchronization state with HTBNS util minus SR state, then I'm going to see that it's a trailing node which is synchronizing itself. And the active node is now site number 2, which is SUSE node 52. So my SUSE is up and running. I'm synchronizing my things again. Now the last thing I have to do, I have to become super user, and I'm now going to restart Pacemaker. Pacemaker is going to get started again on SUSE Node 52. it is synchronizing itself with node. It's going to set on 51. It's going to synchronize itself with the other node. It's going to check the status of SAP. It's going to check the status of the IP address. And after a few minutes, it'll pretend that it started. If you do it right away, then it pretends the services are still stopped. I'm now going to check here again whether my HANA is still running. Yes, it is running. I'm probably going to check again on what my synchronization status is. And it should be still a resyncing thing, which means that the cluster respects the current configuration. And yes, site 2 is still the leading one. The cluster didn't change the configuration. I'm now getting back in here again. I checked with Studio whether my synchronization works as well. And here you can see that it's now syncing to from node 52 to node 51. The last thing I'm now going to do is I'm going to check again with, I'm doing exit. Then I check again my cluster status with CRM status. And now I can see the new master is 52. The new slave is 51. The IP address is pointing to my secondary node. And I'm back in again in a high available configuration. And I'm ready for the next disaster waiting to happen. Yes, this is pretty much what I had on the demo. This is kind of close to the end of the presentation. We are working to improve our solution. We are about to write a white paper for interested customers explaining what we can do. We are going to test scale-out scenarios as they're already being supported for our on-premise customers. And we are probably going to add improvements to the handling of the IP addresses. We have some customers who have some proposals on how to do things in a better way. We're working on a DNS failover agent. And therefore expect to see quite a number of improvements in the next half year. Everything works with /12 SP2. This is the software version you probably will want to use. If you are using SP1 out of the box, take care that you do a zipper update. There are some important bug fixes there. And 12 SP2 is basically the release you want to go because it has as well network drivers for our X1 instances. So you get the full performance out of our 1 and 2 terabyte systems. Peter?
Yeah, so
something missing?
No, so I think we're ready to open for questions.
Yeah.
What is the biggest size of the database that you've tested this configuration of?
We have 2 terabyte systems, and we tested as well on 2 terabyte systems. But I don't know if we have a production customer who's using these instances. We have these instances now for 3-4 months. And I'm not sure whether we already have production customers on these large instances.
Is there any plans to consider an on-prem with a DR in Amazon or a different cloud provider configuration?
So you want to fail over from an on-prem system to cloud DR? Well, we have Fabian here. Can we do such a stunt?
Depends a bit if you would be able to have a layer 2 network. Of course, you must know the IP address or routing. And in the AWS cloud, we have a routing solution for it. If you have a layer 2 network, we have an easy way to just take over an IP address. So it depends a bit on your environment.
Yep. And the point is, we do this based on an IP address. And we would have to change the IP address to be from on cloud to be on premise. This would be probably a major stunt in any router.
Yeah, maybe one issue could also be you need then heavily to test the network connection to the cloud, because you can imagine that the SAP system replication network needs a lot of bandwidth, so typically 10 gigabytes.
Yeah.
It's not so easy, not a normal.
I'm going to come to you. Yeah.
Any consideration for like a VMware cloud, or is that only for AWS that you're
we just announced a cooperation with VMware. VMware is going to run their own service on AWS. We work with them on certifying everything on for SAP. The VMware environment is going to look at the first, second, and third look like a VMware environment. So you would have to use agents being used for VMware to fail over within a VMware cloud on AWS.
Yeah, so it's the normal scenario what we have seen before.
Yeah.
Not with the special agents for the AWS, where we talk to the AWS infrastructure because it behaves like normal because it's the VMware which is doing that.
What is the performance impact in doing a synchronous application and reputation?
What do you mean with performance impact?
Yeah, I assume that will have delayed performance in doing this application.
Yes. This is something where you will have to do some tests on your own, because our data centers are being built where they thought they need to be built. They have different flood levels, different electricity hookups, and we warrant that our availability zones are 10 to 50 kilometers apart. And this is simply different in the different regions of the world. We typically see a latency less than a millisecond. And we see that synchronous replication is relatively well wherever we test it, like in US East, Ireland, Europe. But there may be cases where synchronous replication is not anymore appropriate for higher paced applications, where you may have to convert it to asynchronous replication. And
also a bit depends on your workload you're running. If you are more looking on applications, I would not expect a big performance issue, because then you are always running local queries and they are fast enough. So only having massive data change in the database, of course, from the SAP side must also be a bit postponed, because if you want to have a synchronous system application, your commit would for some time be postponed to the second side commit that you have written to either memory, syncman, or even to the disk, so the synchronous completely. And just like ERBD mirroring devices over the network, we have several levels of security of data integrity. Of course, they have some impact. So I would not say it is just a percentage, because heavily depends on the workload.
yeah.
I mean, this would also be a direct question to SAP if they have some experience of how much impact this is to the ERP system or in EW.
Yeah. Another aspect which you have to realize, you have to make a clear analysis on the errors you want protection against. In AWS, we have virtual machines which we assign to physical machines, and if a machine breaks or fails, then a user can simply hit the restart button and we assign new hardware to it using the same disks. So we basically have an auto restart for failed hardware being built in, and therefore, if your key worry is problems on the motherboard, then we have auto restart being built in. System simply reboot on new hardware. This helps us well with scale out, and therefore this multi-AZ solution is really something which is more against an entire AZ failure. And if you want to, you can operate both in the same AZ. You can even force them to sit in the same in the same rack. Then you're going to pay some 10–15% more, and then you have maximum bandwidth in between. There have been a question.
It's more of a comment. I know when customers are looking at replication from one region to another, they usually are looking at asynchronous replication. And I know your question was around an internal data center or physical assets from a different platform to AWS. And with AWS, you have the ability to have a direct connect or dedicated lines dropped into the AWS infrastructure. So it would be more of an asynchronous replication. But you would always solve high availability within, a low latency network. You wouldn't want to wait to perform those commits to the secondary node. Otherwise, you're slowing your application. The white paper, weeks or months away?
I think it won't be done for Christmas. But we're pretty sure to have it before Easter.
It needs to be, so it's written technically, but we need to make it more shine and going through all that Marcom stuff. So
yeah, we have a pretty packed schedule before Christmas. We have a number of new instances. We have a number of certifications. We have this VMware project. Read this SAP note. This is a fairly comprehensive write-up on what you have to take care for.
Just a short comment to the question regarding the performance of the synchronization also. Synchronization. So basically, that's your own option. Because the second option is just the application based on the storage level. But this is slower because then you are replicating in memory, but then you are replicating on storage level. So basically, it's a question about how much does it influence the performance, because you either want HA or you don't want, because there's no other option. So it doesn't matter if it's AWS or if it's on-premise, it's the same, the performance issue on the SAP HANA side.
The question to the performance issue is valid because you need to calculate it. So if you want to have some SAPs in your company system, you need to have some, you need to reserve some capacity, some power to fulfill the requirement.
Yeah.
Basically, you have a third-party machine AWS, so
yeah. And keep in mind, everything is highly dynamic in AWS. If you figure out that replicating into another AZ is going to be kind of too slow, an advanced admin can recreate a system in the same AC within 15 minutes. Or you can shut down your system, fire it up in a bigger or smaller configuration. We are extremely flexible here, and it typically takes a bit of experimenting. Okay, some more questions? No, then thank you for attending our very late session. We appreciate it a lot.